in the video on triangle medians and centroids. I did essentially the proof that the centroid is 2/3 along the way of a median. I did it using a 2-dimensional triangle in 3 dimensions. And I mentioned that I thought at least it made the math a little simpler. But someone mentioned that they'd be interested in seeing the 2-dimensional version of the proof. So why not do that? So let's just draw an arbitrary triangle. And I'll make one side of the triangle right along the x-axis just to make, I think it'll make the math a little bit easier. Maybe there's easier ways of doing it. So that's one side of the triangle. That's the other side of the triangle. And let's put kind of the height of the triangle. The height of the triangle, let's put it on the y-axis. So let's put so this triangle right here, this is the y-axis. That is the y-axis. And then this right here is our x-axis. Now, we said that this is an arbitrary triangle. So let's just make this distance equal to a. So this point right here, this vertex would be the point a, comma 0. So that distance is a. Let's make this distance right here be equal to, I don't know, let's make it equal to b. So this is the point negative b, comma 0. And then let's make this distance, this is the point y is equal to c. So this is the point 0, comma c. So it's an arbitrary triangle. Any triangle can be represented this way. Now let's think about its medians. Let's think about its medians and the centroid. And I'm only going to do for 2 of the medians because we know that the third median will also intersect at the same centroid. So let's just find, so we have a median on this, we have a midpoint, I should say, on this side of the triangle. And its coordinates are just going to be the midpoint of those 2 points, or 0 plus a over 2, which would just be a over 2. And then c plus 0 over 2, which would just be c over 2. And let's do the same thing over here. The midpoint of this side right over here is going to be negative b plus 0 over 2. So it's negative b over 2. And then 0 plus c over 2. So it's just going to be c over 2. Now that we know all the coordinates for the vertices and the midpoints, at least of these 2 sides, we can find the equations for the lines that the medians are part of. So we could find the equation for this line. We could find the equation for this line in purple. Then we can find the equation for the other line that connects these 2 dots. Find their intersection, and we'll essentially have the coordinates of our centroid, of the intersection of the medians. And we could do it for this one too, but that would be redundant because it's going to intersect in the same point. So what would be the equation for this line right over here? Well, our slope is going to be change in y, so c over 2 minus 0, so that's just c over 2, over change in x. So a over 2 minus b. So it's minus negative b, I should say. So it's plus b. I could write a plus b over here. But just to make the math simple, I'll write plus 2b over 2, right? I just subtracted a negative b, which is the same thing as adding a b. And adding a b is the same thing as adding a 2b over 2. And I did that so these have the same denominator. I could add them, or I could just multiply the numerator and the denominator both by 2, and I'll get the slope is equal to c over a plus 2b. So that's the slope of this line right over here. And then we know some points here. We could just use the point slope formula for the equation of a line. We know the point negative b, comma 0 is on the line. So we know that the equation of this line in purple, let me stay in the purple, is going to be y minus 0 is equal to x minus negative b, or I could say x plus b times our slope, times c over a plus 2b. a plus 2b. And obviously, this would just simplify to y is equal to all of this business over here. So this is essentially the equation of this median right here, if the line just kept going. Or this line, the median is a line segment that is part of this line. Now let's do the same thing for, let us do the same thing for this line right over here, this median right over here. So once again, its slope is change in y over change in x. So the change in y, c over 2 minus 0. So the slope here is equal to c over 2 minus 0, which is just c over 2, over negative b over 2. negative b over 2 minus a. Or I could say minus 2a over 2. That's the same thing as minus a. And do the same thing. Multiply the numerator and the denominator by 2. We get c over negative b minus 2a. So the equation of this line right here, the other median, the equation of this other median right over here is, well, we have this point over here, so we could use the point slope again. We get y minus 0. Y minus 0 is equal to x minus a, times the slope, times c over negative b minus 2a. So we have the two equations for these lines. We can now use that information to find their intersection, which is going to be the centroid. Well, to do that, we have both of these in terms of y, right? Y minus 0 is the same thing as y. Y minus 0 is the same thing as y. So we could just set this as being equal to that. So let's do that. We get x plus b times c over a plus 2b is equal to x minus a times c over negative b minus 2a. Well, both sides are divisible by c. We can assume that their c is non-zero, so this triangle actually exists. It actually exists in 2 dimensions. So we can divide both sides by c, and we get that. And let's see, now we can cross multiply. We can multiply x plus b times this quantity right here, and that's going to be equal to a plus 2b times this quantity over here. And so we can just distribute it. So it's going to be x times all of this business. So it's going to be x times negative b minus 2a plus b times all of this. So that's going to be minus b squared minus 2ab. So I just multiplied that times that is going to be equal to this times that. So it's going to be x times all of this business. X times a plus 2b minus a times that. So minus, distribute the a, minus a squared minus 2ab. See if we can simplify this. So we have a negative 2ab on both sides. So let's just subtract that out. And then if we, so we cancel things out. Let's subtract this from both sides of the equation. So we'll have a minus x times a plus 2b. And I'll subtract that from here. But I'll write it a little different. It'll simplify things. So this will become a x times, I'll distribute the negative inside the a plus 2b. So negative a minus 2b. And let's add a b squared to both sides. So plus b squared plus b squared. I want to collect all the x terms on one side and all the constants on the other. And so this becomes, on the left-hand side, the coefficient on x, I have negative b minus 2b is negative 3b. Negative 2a minus a is negative 3a times x is equal to, these guys cancel out, is equal to b squared minus a squared, is equal to b squared minus a squared. Let's see if we can factor. This already looks a little suspicious in a good way, something that we should be able to solve. This can be factored. We could factor out a negative 3, or we could actually factor out a 3. We'll get 3 times b minus a, 3 times, let's factor out a negative 3. So negative 3 times b plus a times x is equal to, now this is the same thing as b plus a times b minus a. So we can divide both sides by b plus a. And we have negative 3 times x is equal to b minus a. Well, let's just divide both sides by negative 3. We get x is equal to b minus a over negative 3, which is the same thing as a minus b over 3. So we have the x coordinate. So far for our centroid. It is a minus b over 3. It is a minus b over 3. And you kind of see hints of the solution over here. A minus b is this entire distance. It's 1/3 of this entire distance. Although I don't want to jump the gun too much because it complicates it just thinking about just the x coordinate. But let's figure out the y coordinate. To do that, we can just substitute back into one of these equations up here. This was the equation of this median, the gray median that we had done. So let's substitute back in. We have y is equal to I'll do it over here. Y is equal to x minus a times c. X is this thing over here. So it's a minus b over 3 minus a. So I'm going to subtract, instead of just writing a minus a over here, I'm going to write a negative 3a over 3. So minus 3a over 3. That's this minus a right over here. I just multiplied it and divided it by 3. It's going to be all of that times c over negative b minus 2a. So this is going to be equal to, see, in the numerator up here, we have an a minus 3a. So this is equal to negative b. We have a negative b there, and then we have a minus 3a is minus 2a. So this becomes negative b minus 2a times, we could factor out the 1/3, times c over 3. So that's what the numerator is. All of that over negative b minus 2a. Well, that's going to cancel with that. And so our y-coordinate is going to be equal to c over 3. So our y-coordinate over here is c over 3. Now, we could just use the distance formula now. We know all the coordinates, and you feel free to do it if you like. But there's a slight simplification, or at least in my mind, a slight simplification. We know that the height, we know that the y-coordinate of the centroid is c over 3. So this right here, this point over here, is c over 3. So we could actually use maybe an easier argument, because remember, our whole point was to show that this point is two-thirds along the median away from the vertex. So let me draw this vertex now here. Our whole point of this video is, we said this is the midpoint of this side over here, is to show that this right here is two-thirds along the way, or that this length is twice this length, or that this length is two-thirds of the entire length of the median. So how can we do that? Well, the simplest way I can do that, I mean, you could actually just use the coordinates and use the distance formula. But a simpler way, just the way that we've arranged this, is just to use an argument of similar triangles. Because this right here is, we know that this entire height right here in blue is c. We know this entire height over here in blue is c. We know that this height right over here is c over 3. Or you could view that as 1/3 times c. And so we know that this height over here, we know that that distance is two-thirds c. So we can use a similar triangle argument. Let's say that this entire thing right here is the length of the median. And let's just call that, I don't know, let's call that L. And let's say we want to figure out how far along the median away from the vertex that is. And let's just call that, I don't know, let me use another, let me just call that distance right over, let me do this in a different color. Let's call this distance right over here. Let's see, I've already used A, B's, and C's. Let's call that D. So if we can show that the ratio of D to L is two-thirds, that this is two-thirds of the distance, then we're done. And we can use that by similar triangles. We have two similar triangles. We have this, let me use a new color. We have this triangle, which is kind of embedded inside of this larger triangle right over here. They both share the same vertex, this angle over here. They both have right angles over here. And since they have two of the same angles, their third angle has to be the same. So they're definitely similar triangles. So we can just set up a ratio here. Two-thirds c, which is this length right over here. That's this kind of the vertical side of the smaller triangles. We could write two-thirds c over this entire length, over the length of the larger, that's this corresponding side of the larger similar triangle, over c is equal to the hypotenuse of the smaller similar triangle, d over the hypotenuse of the longer similar triangle, or the bigger similar triangle, d over L. Well, this is clearly, just divide the numerator and denominator by c. This clearly becomes two-thirds. So the ratio of this length to this larger length is two-thirds, or this is two-thirds a long way along the median away from the vertex. So there you go. That's the two-dimensional proof that the centroid is 2/3 along the way of any median from the vertex, or 1/3 along the way along the median, or 1/3 the distance of the median from the opposite midpoint. Anyway, hopefully you enjoyed that.